All right, so let's get started. This one is lecture number 5 off of the behacker.com website. And I know I'm skipping around a little bit. We've barely finished lecture 1 and now I'm going to 5. It's because of the content. So if you go through them in order, it's a little dry because it'll go through syntax, 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 syntax. Okay, we're done with the syntax. Now let's go to design patterns, and then let's go to, and if I don't mix it up a little bit, put everybody to sleep. So long story short, we're skipping all the way ahead to lecture number 5. Talk about design patterns. I want to talk about model view controller and UML and how object orientation works with this, because I use the terminology in Xcode, and we're going to see it later with a couple more projects. And you'll be like, I keep talking about the view controller, keep talking about the view, keep talking about the data model and the app delegate and all this other stuff without even like introducing what it is. So this is core kind of to the interface and to the design, and it's called a design pattern. Object orientation uses UML, Unified Modeling Language, if you've never heard of it. If you've taken a C++ course or a Java course, maybe you've heard of UML. UML and patterns are two software design tools used in the context of object-oriented programming. So what we're looking at is UML is actually a separate language in itself, and it's graphical. So you drag and drop icons and things. In fact, if you're on a Mac, you can use a program called OmniGraph. And OmniGraph, let me actually just bring that up actually.
Is it similar to Visio?
OmniGraphal, excuse me. I'm sorry?
Is it similar to Visio?
Very similar to Visual, but it's actually free. There's a paid for professional version of it, but we have it for the Mac, for the iPad. It only works on the Mac. It only works on Apple software. Great UML tool. Great design tool, actually, because you can design a build. Here's an example of a build. It's a game. You can use it to write UML designs for apps, for iPad and iPhone apps. If you get into this, people aren't going to want to wait for the final product. They're going to want to see a design ahead of time. Great for prototyping, great for UML. Uses a model view controller. You can do wireframing in it. So just looking at here. This is not a sales pitch because this program is available for free. There's an upgraded version of it. You can also donate. But to go to omnigroup.com, it's OmniGraphal. I said it wrong. Originally it's OmniGraphal. And you can just Google it. Feature list down here. I believe the Pro version, I don't know. One of them is probably a paid for thing. The other interesting thing is you can design on the iPad, transfer the design over to the MacBook and back and forth. So you actually have the capability of doing some sophisticated designs. I actually downloaded yesterday or a few days ago. I used this program, so I also downloaded the tool set that gives you the interface for GUI components for iPad and for iPhone applications, so you can see the same components. Although it's not 7, it's on 6.1, I think, at this point. But long story short, UML is used as the modeling language in Microsoft Visual Studio, or Visual, what is it? Visio, actually. Visio is the product on a Microsoft system. However, that's not going to really help you in iOS development or Objective-C, because it's Microsoft. So if you want to do the Apple route, you want to go to some tool on an Apple system to actually do it with. So what you're creating are objects, and the objects have relationships with each other, and you're identifying the 3 components: the identity, state, and the behavior of each one of the objects, and how the objects are interacting with each other. So that is the basis. You can take an entire course in UML. In fact, some object-oriented design. Of course, we haven't really taught at ITU yet, but I'm thinking in the future I might even want to teach that course, actually. The course would just be on design and design patterns, where you would actually learn UML. Because that's one of the problems is, like, in software engineering and programming and development, people go, oh yeah, here's a UML diagram. And you bring this to a meeting, and you're like, wow, who created that thing? You know, what were they thinking? You know, and it's like, actually someone here did this at one of the meetings I attended recently for the EMS team, and it looked like a big spider web. That's the only way I could describe it. I looked at that and went, whoa. And you're going to catch some spiders with that one, because you couldn't understand it. So there's quite an art to actually creating good diagrams, which is why kind of the subject matter lends itself to another class in itself, because it's like UI design or UX design, and you're basically designing not only the interface but the software itself and the components of the software. So it's a design pattern, and a design pattern is a programming of a kind of template or outline for a software task. So UML, there's some tools out there that actually, for C++, that actually create pseudocode, or they actually create source code for you. You click a button, it says, produce my classes. So there were a couple of tools out there. Rational Rose made one. I think Adobe at one point, or maybe it's brand new, I'm not quite sure, has something where you have business people, software developers, or business people. You don't have to have a programming background for this. Drag, drop, design, using a GUI tool, design the application, design the interface, design the components, the data, the views, the controller, everything. And then press a button, and it produces source code template, which is just basically the empty classes with the methods and the data that's in there. And it pretty much sets the stage, and then you give it to the programmers, and they make it work. They build it for you. Because a programmer is probably the last person who should be designing this app. Because they have really good technical skills in programming, but they're not normally UI designers or UX designers. They're not really good at that. They're more computer science, programming kind of people, which is my problem. I mean, I can actually write the code, but I can't design for my life. I couldn't save my life designing. If somebody else gives me a design, no problem. I can follow instructions. But, talk about, color combos, user experience. There's a whole psychology behind it. It's a whole separate field in itself. There's actually, when you talk about psychology, actually, that's the whole trend with user experience. They have these tests where they, 5 different apps, all same functionality, just 5 different interfaces, give it to a focus group. And they say, how do you feel after you use it? Oh, I feel happy. Oh, I feel sad. They're like, why are you asking, programmer stands there and says, why are you asking how they feel about it? It's like, well, that's going to make the product work, actually. It has nothing to do with the source code you're writing. It's, do they like it? So, which is actually kind of a risk you take, especially with, actually now looking at iOS 7, kind of a risk that they took with the drastic changes that they made with that interface. And I'm thinking, actually right now, I sort of like it. Actually, it's more professional. It's less of a toy. And obviously this morning I've been looking at it because I upgraded it last night so it would work with my Xcode. And I've been thinking, well, how do I feel about it? And I wasn't really quite sure yesterday, but now I'm starting to feel it's more professional. I feel like it's more of a productivity tool than a toy, actually. Because now, everything's condensed. It looks like and as I mentioned earlier today, it looks like a desktop system. It looks like a computer. It doesn't look like a mobile device anymore. Or the interface gives me a feeling of and unfortunately, you don't know what the feeling that your customer is going to get from your program or from your application until they actually use it. Which would be kind of interesting to see what the response is out of that. I like it because I'm sort of a minimalist. I don't like a bunch of crap on my desktop. I don't like, I only install what I need. I like the thin. And now I looked at this thing and went, wow, white background. No more button borders. No more frills. No color all over the place. It's very dull. It's very pastel. Like pastel colors. Nothing too bright and flashy. It's very subdued. I look at like some of the Chrome browsers and the Google tools. And I'm like, it kind of looks like my desktop. And it's like, wow. They took the wow factor kind of out of it, and they made it into. And then my original response to that was like, I don't know if I like it yet. I'm still kind of toying on it. I don't know if I like it yet. But, if you want to see it later or during the break, I have iOS 7 installed here. So you might want to check it out just because before you update your phone or before you update if you have a device. Take a look at it if you want. They should have shown it to people online. They should have demoed it because it's significantly different. But I know I can go backwards.
It's more closer to Android now.
It's closer to Android, you're right. Which is actually kind of funny because I liked the Apple look.
We have the Android.
And you guys are Android people. Oh, I have an Android person too. I have a Samsung Android tablet. So I use it. And I teach Android development. I'm like 50-50 around the east side of the fence here. But long story short, it's going to take a while. It's going to take a while for me to get used to it, I think. But I don't know if I like it yet. We'll see. But the UML actually allows you to put the design out there, get the UI UX out there. Also get, it's more traditionally used for source code development, for design pattern of the application build. And producing pseudocode or source code representing, you know, kind of like the design in sort of a mathematical kind of way. So it simplifies the design, eliminates details of the programming language syntax, makes it so a non-programmer can actually use it. And graphical, flowchart, structure diagrams, and stuff like that as well. And it supports, and as I mentioned before, it stands for Unified Modeling Language. And it's...
The pseudocode is just like a template.
Pseudocode is fake source code. It's not real source code. It's pseudo. It's not a template. It's like, you know, if I go to the store, then I do this. If I don't go to the store, then I'm going to do that. If I go to the store and do this and that, then I need to do this. And you write that down, like, if I go to the store, yada, yada. You write it in English. Some people used to call it structured English. It's pseudocode. Not source code, but it represents an if-then-else structure. That you take that to a program and go, okay, if A is bigger than B, then, and then they write it out.
Like logic.
Logical representation of the source code without writing source code. People who use pseudocode are not really programmers. They're software developers. You can have a really nice career in software engineering and never program a line of code. Programmers are a totally different breed than a software engineer. So if you're a programmer, you're going to write this programming code. I would, you know, some people would just prefer to write the source code. Other people, software engineers who don't know any languages, don't know any programming, they write pseudocode. Because then they learn pseudocode languages, and then they're the ones usually using UML as well, because they're the ones. See, if I were to take like 5 people, or 4 people making an even team, I got 2 programmers and I got 2 software engineers. Put them behind a wall so you can't see them. Right? Give them a task to do. One group, the programmers, would actually just write the code. The other ones would actually write the pseudocode, and they would do the UML. And they would actually come up with a better product than these guys over here. But these guys would get done faster. So it's like trying to teach a programmer to be a software engineer is an interesting task. It's easier to teach a software engineer to be a programmer because they have better design skills normally, and they have a better capability of being able to see the big picture and pre-plan it versus just write it. The programmer wants to make it look as cutting edge as possible, and they want to put everything but the kitchen sink in there. They want to cram it up, and they want to write the code right now. Why waste time writing pseudocode? So pseudocode is, and I said, why waste time? Really, pseudocode is the right way to do it. It's not a waste of time, but your software engineer will work with it. Your programmer will just toss it out the window, just like documentation. Just toss it out the window. We don't need documentation either. So, all right. So history of UML. UML actually came out in the early. In fact, the funny thing is this guy here, sort of, there's like 5 or 6 different authors of object orientation, because this is object-oriented programming in Objective-C, and this is the first weekend of the class. So I'm going to give you a history today of object orientation. I'm also going to give you the history of Apple as well next coming up. So you can kind of have a little history lesson. This is the history part I was promising yesterday. This guy here is like the Brock method. Actually, there's a book called The Brock Method, UML by Design for Java. So we got Java, Smalltalk, Objective-C, C++, and actually JavaScript is also object-oriented. Doesn't follow true object orientation though. All these different languages that are object-oriented programming languages. All right, well, where does that come from? Well, it comes from the original study, the original research, and the original creation of this methodology. It's only a methodology. Its implementation varies among its several different languages that were dialects of it. So we're just speaking a different dialect of it with Objective-C. Same dialect we're speaking with Java and C++, or different dialect, I should say. Only around 1996, not too long ago. Well, okay, I don't think it's too long ago. The guy that I highlighted here, and you can see it on there, is probably the most popular person, most popular implementation of this. Why? Because he just has a better way of explaining it, I think. and his books, and he's authored several different books on this subject, UML by design, UML distilled, all this stuff. If you study UML and never touch a programming language, you'll have a better understanding of object orientation than you would if you just studied programming, which is actually kind of ironic. So you take an object-oriented design course, OOD instead of OOP, you learn about UML, you learn about object orientation in general, then you take that concept and you apply it towards half a dozen different languages, and then you know what you're doing, which is kind of the better approach to it. Unfortunately, students don't want to do that. They want to learn C++, they want to learn Java, they want to learn Objective-C. So you're learning the language with the underlying concepts of object orientation, but you're never learning the design part of it for the most part. There's these other guys listed here. They're the earlier versions of UML. They developed UML, they developed object orientation, they developed the concept in general. Not to say that other people don't get credit. So people on YouTube usually come back and say, what? Wait a minute, you're leaving out the most important person from Smalltalk. I'm like, okay, wait a minute now. So if you go back to Smalltalk, Smalltalk was actually in Adele Goldberg and the Goldberg group. Well, those are the original authors of it. It's kind of like Dennis Ritchie to C relationship. Dennis Ritchie is probably the godfather of C. Goldberg is probably the godfather of Park Place of Smalltalk. But long story short, they came out with these ideas. I'm sorry?
Brady or Brady?
Brady.
It's Grady.
Grady. Excuse me, it's a misspelling. It's a G, not a B.
Oh, Grady.
Grady. Oops, Brady. I have to correct that. The guy's name, well, just look at this. The last name's spelled correctly. So, anyway, don't quote me on this. Google it. You'll get a better information. It's Grady. So, yeah. Thank you for the correction. I can't tell you how many times I've done this lecture, and this is the first time I've noticed that, actually. Well, the funny thing is people never remember who actually invented anything, who did anything. But I remember Brock as the Brock method. And he uses his name. I don't even pronounce it correctly. So, long story short, I look at that and go, oh, I recognize that. But I don't recognize his first name because it's never written on the books, on the cover, and the titles of his books. But anyway, long story short, Smalltalk was a language for printers. Originally came out of Xerox. What does Xerox make? Printers. So they came up with this language to control the device. Printers have operating systems on them, and Smalltalk was an operating system to control the Xerox printers. And then we had Xerox PARC that came out of that. We said, PARC, well, this is a pretty good language. And people started thinking about it, and this is back when object orientation was being, what about object orientation? Long story short, it turned into Park Place. So now it's Object Share. Actually, it might not even be Object Share anymore. It might be something else. This is talking about like the 1980s or so. This is a long time ago, actually. So after Smalltalk came Java. Java came much later than Smalltalk. Smalltalk, they said, well, actually one of the 1983 or 84, I think it was, the Olympics, used a Smalltalk clock, actually, for one of and that was the first kind of like usage of the language outside of printing and outside of development. They actually used it for the Olympics, the US Olympics, for some sort of a clock mechanism. And then they went, oh, this is great. So then the original version of Java was developed by people who learned Smalltalk, liked the format, liked the language, wanted to make it easier, and wanted to put it on the internet, wanted to make it cross-platform compatible. Where Smalltalk wasn't quite cross-platform, it was a server-based language to start out with, then it turned into a PC kind of language, but it was still kind of not really mainstream. Java was more of the mainstream kind of focus towards it. Make it so it works on desktop computers and it works on the internet, it works on anything, not just these mainframes or not just, or printers and stuff like that. Which was funny because in the earlier version of the mobile phones, we have Java. Java started out as an operating system as well. So Smalltalk was an operating system for printers, Java was an operating system for printers, for mobile devices, for the old style kind of embedded system kind of small little language. Why? Because it creates a small little file. It was a very small footprint because it wasn't including everything in the operating system. It was cross-platform compatible. It still is today, but it's controlled by the system that's using it. So you just load it on the system, you make the system, you give it a JVM, you give it a virtual environment, and then the program itself can just run on it, which was sort of like the way Smalltalk was originally designed. So long story short, Smalltalk is still around today, still being used. Heavy influence on a lot of these other languages. So back in the C, let's go talk about C. C came around, Java's out, Smalltalk's going pretty well, the government's buying in and funding some of the stuff for the Smalltalk development. And then C says, well, we want to be object-oriented too. So then they got C++ that came out of that. And the people looked at C++ and went, oh my, that's not object-oriented. Whoa, that's not good at all. And so the other side of the fence went back and said, well, we got Smalltalk, we got Java, but we need a C dialect. So that's where Objective-C comes into the picture. So Objective-C is a product of the people who developed Smalltalk, looked at Java and went, well, that's really nice, and then went, we don't have a C dialect. We don't have an object-oriented version of C. So now we have Objective-C coming out of this movement. Objective-C follows strongly on Smalltalk, strongly on the Java side of the fence. And then lo and behold, over here on the right-hand side, all by itself on a planet of its own is C++. And then later on, C++ went, well, okay, we need to be more like Java. We need to be more embedded, we need to be smaller, we need to, okay, let's go for C#. So we get C# that comes out of that, which was, okay, let's be more like the other people over there. So now we got C++ plus Java, plus a little bit of Smalltalk influence, but not much. And now we got C#. That's why I say C# is a better language, actually, to get familiar with. If you're going to do Windows app development, it's done in C#. Because you can't use C++ for it. C++ is limited. Not quite. And those people who love C++ are going to be throwing stuff at me right now, but it's not the best implementation of object orientation. It's not the best language. In fact, actually, I can't really put a judgment on it. I can't even say that Objective-C is the best language either. Objective-C is kind of convoluted. Huh?
Objective-C is only for Mac, right? It's nowhere else used.
Unix. Unix, yeah. It's a C++ GCC compiler compatible language. It's used on Linux, Unix, and Mac. This is BSD.
That's a C++, right? You're saying
No, Objective-C. You can go buy it yourself or install, like so we were saying yesterday. This is a MacBook. I can go to a BSD terminal prompt into a shell and type GCC and compile Objective-C code.
Yeah,
I can go on a Unix system, Ubuntu. I can install Ubuntu, install the GNU step, which adds the stuff to GCC, and I have the same capability.
Mac is a flavor of Unix.
It is.
Yeah.
So it's a Unix-based language. Yeah. Objective-C is completely Unix-based. Comes from a Unix dialect. Mac is a Unix platform. I'm going to get through the history of NextStep in a few minutes, but it's more Unix-like than it is DOS-like. And other people will complain now when I say Windows is just a variation of DOS, the disk operating system that started out long time ago, because it is. We had MS-DOS, we had PC-DOS, we had, I can't remember what the other DOS was, TDOS. We had a bunch of these different DOS versions, disk operating systems that gave us a terminal prompt. It was for non-Unix. It was kind of a, hey, let's make another operating system. And then they loaded Windows on top of it. So then it's like, oh, we need graphics. And then they made a version of C to work on that over there. And then we have this version over here, we got this version over here, we got this version. C came out of Linux, by the way, Unix actually. Unix is written in C. If you go down to the Dennis Ritchie time frame, who was developing, well, BSD was actually the original version of the Unix from Berkeley Labs. But long story short, the whole history of it's been around much longer than Windows, much longer than the DOS thing. Yeah, Objective-C follows more of the Unix breed, the Unix history. So Unix was around first, MS-DOS, PC-DOS, Turbo-DOS, or whatever that was called. I don't know. A bunch of people came out with these DOS systems. Came out much later in the history. If you take programming language concepts, you get the history of all those languages. So anyway, the purpose, going back to here, around 1996 or so, we have the formalized methods, the books that come out, the methodology that comes out. It says the purpose was to produce standard graphical representation language for object-oriented design and documentation. And since then, it has been revised over and over again. Actually, languages themselves have been revised over and over again as well. So UML usually starts out with what's called a class diagram, because we know that the class in any one of these languages is equivalent to the object. It's the template for the object. So we have the class, which is the central concept, and it's the easiest one. So most people, when they take UML or they learn it on their own, they discover what the class is, and then they implement class diagrams. And then they use the class diagrams as most of their modeling. The interesting thing is that we have about dozens, a couple of dozen or so different modeling types, modeling diagrams, and half of them are not used because nobody really studies UML for the most part, so they don't know all of the options that they have available to them, which is kind of interesting. So we can divide up the class diagram into 3 different sections, the top, the middle, and the bottom. If we look at that, this might actually kind of look familiar. This pluses and the minuses and the tildes and the pound symbols. The original version of UML came out of the Smalltalk development, so a lot of the symbols that are used in there are used in sort of the Objective-C language that came out of that whole line of thinking. So we have symbols like the minus sign and the plus sign, but they mean different things. They'll mean different things in UML than they do in the object-oriented language of Objective-C. So the data specification for each one of the pieces of data in the UML diagram consists of the name, followed by a colon, and then I'm just going to show you an example of the class diagram, just so you have a little bit of perspective on what it is I'm talking about. The name of the object or the class also precedes by a character that specifies its access type. Its access type, that's where the terminology comes from for public, private, and protected in terms of access type in every language, and object-oriented languages, that is. And then we have the minus sign, the plus sign, the sharp sign, indicates public access, private access, protected, package. So C++ actually uses the words public, private, protected. Objective-C doesn't use any words at all. It follows UML. UML says that data members are private, member functions are public. So if you noticed yesterday when I was writing the code for some of the things we were doing, never once said the word private or public or anything, because it follows UML standard. So Objective-C, you can actually do a 100% UML diagram, 100% implementation using UML, and it translates completely into Objective-C code. Also follows model view controller, which is the design pattern for object orientation, which I'm going to talk about next. Follows 100%. You can't do that with C++ at all. And well, you can. You can partially do it with C++, you can partially do it with Java. But as you look at if you take it from a UML perspective, if you actually study UML, you'll see that that's really the true documentation and the true design pattern methodology for object orientation. And then you can start comparing the different languages and go, well, that language supports this concept, but it doesn't support that concept. This language lacks that. And then you start seeing the differences between the different languages. And knowing the differences can help you kind of understand the big picture, especially if you're trying to design your own language. Now, obviously, I'm teaching you from a graduate perspective, in that, if you're a graduate student studying this, you're interested in either going into a PhD level or you're interested in actually doing something applied with it, which means beyond the basic concept of what the programming language is doing, what if you wanted to write your own compiler? What if you wanted to write your own object-oriented programming language, which, if you're a graduate student, you should be able to sort of be thinking along those lines, hopefully, maybe, if that's your goal, or in terms of, depending upon your background, what it is you're interested in doing. Long story short, if you study UML, you have a better chance of creating a pure object-oriented implementation than if you don't know anything about UML. So, long story short, point I'm trying to make, study UML. If you study UML, if you're gonna write an object-oriented language, you got to study UML. If you want to become an expert, or you want to become good at learning languages and using one, and you want to be a career kind of programmer, learn UML. It will not only make you sound more intelligent at meetings, and it will make your diagrams look better. They won't look like spider webs, and they will definitely produce better designs for you in the long run. And the more you understand what it is you're doing, the easier it is to grow in it. It's kind of like learning a foreign language without learning any vocabulary, or without learning the structure of a sentence, and you're just getting by what you see on TV, which is actually how people learn foreign languages. They say expressions on TV, and all they know are the expressions. Gotta go. Cheers. Bye. You know, and that's all they know. And then you're like, well, you can't really expand yourself in your ability to communicate when you just memorize terms. So, or you memorize sentences that you found that you like. So, kids do that all the time, actually. If you study the development of how a kid learns, have children learn languages, they grow in different stages. Believe it or not, that's what you do with programming languages. You grow in the same kind of stage. And you can tell, usually the interviewer, when you go for a job, they're trying to see what stage are you at. Right? They don't want you down at the bottom. They want you somewhere in the middle. If you're too high, you're too expensive. So they want you in the middle. I want to find someone who's trainable. So, which means we can teach you some more vocabulary, we can correct your sentence structure, and we can fix you. So, and then we can afford you. So. All right, so the method of the UML diagram is indicated by the name of the method, followed by the parentheses, followed by a comma, followed by the return type, yada yada. There's some dots in there that uses the dot notation. Class needs to be given a complete description. So UML, you get a complete description of the class along with its, in fact, let me just go to the diagram. Here's a diagram. So the UML class diagram looks like this. What do we have? The 3 spots here. So the 3 spots is what I said yesterday, the 3 characteristics of an object: identity, state, and behavior. Here's our identity. This one's called the square. Whoops. The states are the data members. We got sides, x coordinate, y coordinate. And we got the behaviors: resize, move, erase, the behaviors that are associated with it. So on the diagram side of it, the minuses and the pluses, well, there's going to be the symbols that are going to be used to tell us. Oops, I was going to go back down. Let's see. Back to the beginning one. Whoops, too far up. I know it was on one of these slides. Here it is here. The minus indicates that it's a private access. The plus is that it's a public. The square, that the hash sign here indicates it's protected, and the tilde, it's in a package access. Which is actually kind of interesting because
So these resize, move, erase, so those
these are methods.
So those like are access rights for the user?
No, I'm talking about the plus, the minus, the hash sign. It's not the user, it's the object's access rights
Of the object.
of the object. Object has a public and a private interface to it. And we have the interface to the object, and then we have the object itself. The object itself is controlled by its interface. The interface is generally referred to as the public interface. The public interface is .h. The implementation is the object itself, that's the .m in Objective-C. Or the .h and the .c++. Or in Java, the .java. Java doesn't, actually Java's funny. Java actually supports a true interface. We can take interface such and such, and then we add the interface to the class. We implement the interfaces. In C++, we put the interface in a .h. In Objective-C, we put it in a .h, which is actually kind of funny. Or not funny, it's just kind of different. So let's see, let me just finish up the slide that I skipped. For the analysis, it's not required that you represent everything. You're just going to represent members. And members and missing members are indicated by ellipses or dots. So here we have 3 dots. So as an example, we have the 3 dots down here, meaning there's more. But this class should have this one, and this one. And so what you're looking at then now is a class, which is an object implementation. So if you're taking a UML approach, and this is just meant to be one example of the UML diagram to see how it looks. If you put a class template together that look like this, then you could connect that with other objects, and then you can figure out how you're going to form the communication between the objects, which is actually kind of a better way of designing. It's kind of like you have a shopping list or you have a to-do list, and it requires you to drive all over town. If you write the list out in kind of an order, like where things are located, do you really want to drive to Fremont, come back, drive to San Jose, and then drive to Fremont again? No, when you drive to Fremont, you want to do everything you need to do in Fremont and then come back to San Jose. And then, so you're organizing things. Well, that's what UML in this class diagram is allowing you to do. So you don't have two classes that have the same functionality. Why would you have that? Or you don't have classes that don't communicate with each other, or classes that don't belong, or classes that make no sense in terms of their naming or in terms of their functionality. So this one is for a square. And the square here has the three sections, as I mentioned before. And these minus guys here, they're saying these are private, because by default everything's private. And then we have the public ones here, and the public ones are going to be resize, move. And then and this is protected, erase. So then we've got the the extra stuff that might be in here as well. Because you're not writing the source code, and you're not writing the entire class. You're just saying, well, what do we need in here to make this functional, to actually act like a square? If someone wants to put in here set color, that's fine. They can add set color to it, or get a color or something like that. So UML actually supports the private data members and the public member functions, and we also have the ability to set get, or the accessors and the modifiers, which is why they call them accessors, because you're accessing this. Because the access is private. They do it as a protective mechanism. If you've ever taken any programming course in any object-oriented language, you always know to keep the data private, because it ensures the stability of the class and the integrity of it. Because what you're going to end up doing is interact that class with other classes, and you're going to create a hierarchy of behavior that's going to build and extend as the program grows. And if you don't have a good foundation, then the whole thing is going to collapse. Building software is kind of like building a house, they always say, when you talk about software development life cycles and methodologies. If you build a really good foundation, then everything on top of it can always be modified and changed. If you build a really good house and then someone removes something from the foundation, the whole thing's going to fall down. So why let somebody remove a supported wall that's supporting the entire structure? Or why let them remove the foundation? Which is ridiculous. Don't do that. Everything just falls down on top of it. So you don't want to do that in your software design either. So if you follow that parallel, you're building software like you're building a house. You're blocking off that foundation. You're not letting it touch with a foundation. That's your lower classes in the hierarchy. You can't modify object at all in any programming language. Object is object. If you modify object, you've just lost the concept completely. If you create another object from object, and then you create another object from that object, and another object from that object, you want the lower ones to pass the information to the higher ones in the hierarchy, but you want to keep that lower one secure. You want to keep the object itself secure. And you think about objects themselves, they're sort of like you. You're an object, right? So I can't go over, hey, I'm going to change your name. You're now Mary. You're not going to like that, are you? So you're supposed to be in control. So you have a set name and a get name function. All right, set my, nope, sorry, not Mary. I don't want to be Mary. Why don't you give me a male name? Okay, why don't you give me another name? So then you can control what name I give you. Otherwise, I just tell you, now your name's this. You're Bob, you're Mary, you're Joe, you're Peter. You're like, I don't want that name. So as an object, you're self-preserving, because you can't just have somebody else change your name. If you're a person object, you're going to change your name. That's ridiculous. But then it's funny how you see programmers do that all the time. They'll leave everything public because it's more flexible. So they go around, oh, I'll change your name now. You're Peter. Okay. It's like, where's the integrity in that object? Where's the protection mechanism? There's nothing. There's nothing to support anything. You just change the object. You were a couch, now you're a chair. Okay. All right. Well, all right. Just change you overnight. Which is not really too safe, because it makes the world unstable in terms of object orientation. So. Access modifiers, can't stress it enough. How to follow the rules on that one. Class interactions, they do interact with each other. Rather than show just the interface of the class diagrams also show and design how they interact among other classes and what they're supposed to do. And then we have various different ways to indicate the information or the flow of objects from one to another. And then we have the annotations of the class groupings into packages, or into inheritance, or into other interactions. So there's an inheritance diagram, there's class diagrams, inheritance diagrams, interaction diagrams, tons of stuff, which is why there's like so many different variations of UML that it's hard to learn UML It's better to get a reference book and say, well, what I'm really trying to show, I want to show the inheritance diagram, or I want to show the interaction or something, and then you figure out what diagram model is there. And not only that, but as I was mentioning earlier with all those authors of UML design, each one of them has its own tool set. So when you open up Visio or you open up one of the other diagramming tools, you got to first decide which author am I going to follow, and then pick their tool set, if that's the one you like. So a lot of people pick the author by the tool set that they like, and they find one that works for them. Hello. You guys all made the attendance. This is excellent, actually.
So these classes.
I've never seen him take it this late. Yeah?
So these classes are the objects itself and also the same as the entities with attributes.
Yep.
So classes equal object equal entities.
Yep. In structured analysis and design, the class or the object is the entity. So an entity, a class, an object are all pretty much describing the same concept. They all turn into objects. If you're looking at structured analysis, you're looking at an entity. If you're looking at object orientation, they call it a class in terms of its implementation.
Can you repeat that? If you're
Objects are objects. Objects are what you're designing. If you're implementing them in a structured analysis approach, you're calling it an entity, because we have entity relationship diagrams. We don't have objects. If you're talking about object-oriented design,
then you call
the
it class.
template for the object is the class. When I say template, means it's the implementation of the object. If we have an object, we want to implement it somehow, we call that data structure a class. Another methodology is called something else. It really doesn't exist outside of structured analysis and design, which is called an entity. So if you study databases, you build entity relationship diagrams. It turns into the data model, which is your class storage or your object storage. So you have students who take classes. You have student table, classes table, and it takes relationship. It turns into another table itself. Which is equivalent to 3 different objects, if you think about it. Which is actually kind of interesting because we now have object-oriented databases that are out. They're following the same methodology. So it's no longer relational. So, I mean, relations are still pretty popular these days, but if you're going to get into databases, study object orientation. It's kind of the wave of the future. So, inheritance diagrams also show relationship between the base classes and its derived classes. Normally, only as much class diagram is shown as needed. We're not going to show extra stuff we don't need. We're not going to show the object. We're going to show the base classes. We're just going to show it from a certain level forward. And derived classes may serve as many base classes or many derived classes on top of that. Each base class is drawn above its derived classes. And upward pointing arrow drawn between them indicates that an inheritance relationship exists. So here's a class hierarchy in UML design, which is interesting because I think the opposite direction. As I know I've mentioned this in several of my classes. I turn the arrows the opposite order and say, didn't we all come from person? And then from person we got student, and then we got employee. And then from employee we got a faculty or we got a staff. But the arrows actually go all the way up. They root up to object. Which I've never quite understood why they draw the arrows upward, but UML draws them upward. I think downward. Purposes of that is when I show diagrams that I've made, they go, oh, your arrows are backwards. I go, it doesn't matter. Because, why, it just is a descendant of person. Now, actually, what it is that these are more, there's less behavior in here. The way this is supposed to read from a UML perspective, and I do understand why, there's less functionality in here. There's more functionality in here. There's more functionality in here. You take it up one more level and put it in an object. That's your entire concept of the language. All the functionality is in the object. So it's big to small. And we have, if you think of it, look at this here. If we go from the small, minute detail, we go all the way back to the large details, large subjects. So a person has everything related to a person. And then an employee is a person. So they're including everything from person, but then they're adding employee ID as an example or something. And then faculty is not going to have very much in it at all. The object itself is going to add just maybe faculty ID. Then we have employee ID. And we have all the stuff that makes up a person. It's included in that. So the level of abstraction is more abstract the higher up you go. And the object is the most abstract concept. So in Objective-C, We say, well, not even make a person, let's just make an ID. ID says you're in here somewhere. You're generic. You're just an object, but you've got everything in you. An ID can be anything and everything. It's at the highest level of the most abstraction in it. It's the biggest object in the entire hierarchy here. So it can hold everything. And then we go downward and we say, well, let's make the ID staff. Okay, let's make an employee, let's make it a student. It can be anything in the entire big picture. It's just an object. Which is actually kind of interesting because if I draw the arrows the opposite direction, I'm not really saying that. I'm saying that this guy goes to this guy. No, it's really the opposite direction. But when I look at this, I like the tree to go down. I don't like the tree to grow up, which is kind of weird because I always think of this like a tree. If I turned it upside down, it would mean the leaves are growing into the roots, which is actually technically correct. But so anyway, draw the arrows any way you want, but no, you're going to get laughed at if you draw them in the opposite direction. So I've been laughed at before. All right, so the arrows do go downward, or upward, excuse me. So let's see. Arrows also help in locating methods and definitions of methods, especially if your documentation is correct. It roots all the way back. So if your documentation is correct and the arrows are pointing in the right direction, then you know where to find the implementation of all of the methods. Because you're not going to necessarily be using the method that was defined in the current object. It's going to be implemented way up the tree somewhere. So look for a method definition for a class. You examine the class definition first. If it's not found, then you move up. You move up the path. There's automated software that does that. There's automated visual tools that do that as well to show you where something is actually implemented. And the arrows show the order of the direction in which you're searching. You're searching up, you're not searching down. You never search down the hierarchy, you always search up the hierarchy, which is why those arrows are going up. So examine the parent class, indicate the connecting arrow, and then if the method is still not found, examine that parent's class and indicate the connecting arrow, and then continue until you find it, which is how you're going to resolve it, which is actually how the runtime resolves it. It works from the current object and it works upward. So if we were to take this diagram over here and actually put it into a class diagram and fill in all the details, we have something that looks like this. We have a person that has a name, and then we have all these methods that go along with the person. Get name, set name, toString, same name, check to see if two people have the same name. And then we have a student that adds a bunch of student stuff to it. And then, I'm not going to draw the whole thing out, but you can kind of see how this works. And then if we were looking at a get name, and we're like, well, we'll look in here, we don't have no get name. We have get student number, no get name, then we go up this way. We go, oh, here's get name. No, okay, so nothing here, we go up this way. So we keep going up, looking for what we want to find. So this is a pattern, and this is a design pattern, and object orientation is a design pattern. So it outlines and applies across a variety of different software applications. And to be useful, pattern must apply across a variety of situations and describe an entire grouping of applications, an entire grouping of things that we can create from the pattern. It's kind of like a cookie cutter, actually. To be substantial, the pattern must take most assumptions about the domain and the application that it wishes to apply for. As an example, the container iterator pattern. A container is a class or a construct whose objects hold multiple pieces of data. If you study data structures, actually some people are in my data structures class, but I don't know if you guys are, not from this class, but teaching it online actually. Long story short, if you study data structures, you know what a design pattern is, because data structures are all about design patterns. The concept of a queue, the concept of a stack, the concept of a container is a pattern. Everything you use it, you can have a stack of objects. You can have a stack of integers, a stack of plates. You can have a stack of anything you want. It doesn't, what you're putting in there, the object doesn't matter. It's the pattern of that particular data structure and data structures in general is giving us our order, our insertion, our deletion, and our manipulation technique, as well as our iteration. How are we going through, looping through, or selecting items out of this structure? So we apply the same thing to object orientation. It's called model view controller. Model view controller is a pattern. Oh, okay, this is actually a good segue, so let me take a break. All right, so I was getting into Model View Controller, but I want to preface that by talking about design patterns. So for Objective-C, actually for Java, the current version of the Android SDK and the Java interface to it is all Model View Controller now, which is actually kind of interesting. C++, not Model View Controller. Never was, never will be. Doesn't follow UML correctly. Doesn't even follow object orientation correctly, so it's never going to follow through this. However, people try to make it work. You can still apply a design pattern. You can apply a design pattern to almost anything you want, to any language, even though it doesn't support it. Objective-C, 100% support for Model View Controller. I'm going to talk about Model View Controller in a few minutes. I'm not going to get into containers or stacks or queues or anything. If you take a data structures course, you'll learn all about stacks and queues and stuff like that. But the pattern is what I want to tell you. It's good to know what a design pattern actually is. A design pattern is the template or the cookie cutter. It's like, you know, in the old days, I haven't seen these in years, but they used to have cookie cutters. You know, around the holidays, you make the little star-shaped cookies and the pumpkin-shaped cookies and stuff. All cookies look the same. But some of them have frosting on them. Some of them have, like, you know, make you hungry for lunch. Some of them have sugar or something on the top of them. They all have the same pattern. Well, that's how you make software. All the cookies look the same. All the apps are the same. They all run the same way. They all have the same things with them. But some of them have sprinkles, and some of them have chocolate, and some of them have vanilla. They all have different toppings on them. But the underlying structure of the app is all the same. So as we build more apps, you'll see it's all the same. We have view controllers, we have views, and we have app delegates, which is basically the thing. So adapter pattern, I'm going to kind of skip through the pattern. I want to go to this one here. It's called Model View Controller. So I can't stress enough, if you are able to comprehend Model View Controller, you'll understand right from the get-go what you're doing. And you'll not have any problem figuring out where the functionality should go and what I'm supposed to do. So Model View Controller is a pattern. It's a way of separating out the I/O task of the application from the rest of the application. Model part, the model performs the heart of the application. That's the app delegate. We got a delegate. It's a traffic cop. It's you can go first, you can go second, and we're going to edit the app delegate. We're going to edit the delegate throughout some of the tutorials that we're going to do. And you'll see how that's the starting point of the app. The app starts up, the app delegate takes over and says, okay, what are we doing? Load this view. Okay, load this controller. Okay. And it's basically doing everything for you. It's the ringleader of the circus. It also stores the main data that's used throughout the entire app. It knows about all the data that's in the app. It knows about all of the different views and all of the different view controllers and everything. Most important part, you get rid of the app delegate, you got hosed. The entire application's not going to run for you. You mess up that app delegate, you got problems. We got the view. The view is the storyboard, or it's the XIB interface. It's the outputs. It's a picture of the model state. Right now, we just loaded. We have this button and this button and this button are here. And then the view is going to, as the app delegate changes, the buttons are going to change. So the app delegate is running in the background. The view is showing to the user. It's the current state of what the app delegate's doing behind the scenes. You can write an app that doesn't have any user interface to it at all. App delegate just sits there on a timer and loads this, loads that, loads this, loads that. It does stuff. A lot of games work that way, actually. If the user sits there long enough, that the screen will go away, maybe, or the screen will do something. Or, hey, you want a hint? You want to know what this word is? It starts out with this, you know, or something like that. You know, it's back there, monitoring the view. The view is the output. The controller is the input part. User presses the button. User clicks on something, or user swipes it. User says something. It captures the input and processes it. It controls the view, controls what is going on in front of the user. So it relays the commands from the user to the model. The model is the app delegate. App delegate's the controller. It says this controller is working right now, and this is your view. So what we'll do probably later today, if not, we're going to do it the second weekend, is create some extra views, put them on extra controllers, change the controllers around, change the app delegate around. So you can see all three. There's only 3 parts to this whole app that we're creating, so not too hard. But it's an interesting design pattern that works. So Android's actually done the same thing. So we have the XML interface view that works with class objects. So we have the main object, and we have the separate objects that work with it. So it's kind of a makeshift. You can actually violate the view concept. You can violate the whole process. Hard to violate it on or hard to do it incorrectly on an iPhone, iOS application, because it's strictly enforced. Not strictly enforced, although it does exist on the Android platform, so which is kind of interesting. Not strongly enforced, because there's a lot of people that don't want to follow design patterns. Android development, Java development, you get a lot of non-programmers. A lot of people don't know what they're doing, never heard of a design pattern, never heard of UML, never heard of object orientation. They're just making it work. iOS part, you get the more serious people. They study UML, they study design patterns, they study... So, which is why if you go for an Android job, you say, oh yeah, I do iOS. Oh, you're better. Yeah, so if you're looking for Android, you want to do Android development your entire career, make sure you have some proficiency in iOS, iPhone, iPad development. Even though you won't be doing it, it shows that you actually know what you're doing versus someone who just does Android. So you want to be cross-platform compatible. You want to have a skill set that works on both. Because if you know iOS, you know model view controller, you know what you're doing. You know the design pattern correctly. If you don't, who knows what you know over here, because it's not strongly enforced. It's Java. So the differences between the two platforms, Java is an extremely easy language to learn. Compared to Objective-C, Java's a piece of cake. So the language skills, it doesn't take a real programmer. It doesn't take a real developer. Easier entry point. So bottom line, the UI is impossible to work with. It's extremely hard. You struggle most of the time to get your UI looking correctly, where it doesn't look beautiful. It looks like garbage. So you actually have to spend a lot more time fixing the UI and working around problems and bugs and issues with different platforms. The problem is you don't have the same hardware. You don't know what hardware you're going to have. Your app looks like crap on this device, but looks really good on this device. Because this device has got a better screen and that one doesn't. Your colors look different. Everything is a mess. But the programming part is easy. Flip it on this side of the fence, Objective-C is a lot harder to learn. You actually have to have some programming skills. You have to have model view controller skill. You got to know what you're doing. And the UI just comes and falls into place. It's like it happens for you automatically. And it looks perfect on every iPad that's out there, or every iPhone that's out there. So you don't spend any time struggling with the UI, but you spend most of your time struggling with the programming part of it. Because programming part of it is so hard. Which means if you're going to do this part of it, you're going to know your programming, you're going to have better programming skills. So you go for you go for a Java job, they know that you know Objective-C, they know you have programming skills. Although you're not going to use them over here, you're not going to necessarily have to use the same level of skills. You've got better skill set. So even though you're not going to do it, it's better just tell them, hey, yeah, I know iOS as well. Because it shows that you're a better programmer. Because over there, on the Java side, those are not good programmers. Those are really crappy programmers. Okay, now everyone's going to yell at me for that one. I shouldn't say crappy programmers. I also teach the Android part. And I'm just saying that Java, if you put Java against Objective-C, you're looking at taking pre-calculus algebra on the Java side versus calculus 2 on the Objective-C side. The skill level requires a higher level of skill to learn Objective-C than it does to learn Java. Java's a much easier language to learn.
And on top of it, Xcode is one junky tool.
I'm sorry?
Xcode is one junky tool.
Is one
It's a junky tool.
junky tool? Yeah, it is a junky.
When compared to
Yeah.
other IDEs.
Other IDEs? Is that a good thing or a bad thing?
Bad.
Bad thing? You don't like Xcode? It's hard to learn.
It's nothing like that actually. It
Yeah.
doesn't have
No?
good intelligence.
Interesting.
Microsoft.NET, if you had ever used Microsoft.NET.
I have the Visual Studio. Yeah,
that's
you're
very
right.
good.
If you compare Xcode with Microsoft Visual Studio, and I can actually fairly say this, I would actually prefer to do iPhone development in Visual Studio.
Yeah.
Yeah. I would actually say the same thing. Xcode has gotten better over the years, but it's a junky tool. I totally agree with you. Take that, compare it with Eclipse and Java, much better tool set. much more flexibility. Okay, so I'm going to compare the tool sets for a second here. Xcode is strict, and all the stuff goes away, and the buttons are small, and the thing is not intuitive. And it doesn't follow like your normal reasoning and logic. It's totally junky. Eclipse, everything's laid out for you. It looks the same in the file thing as it does on the disk. You don't even have to use it. There's a lot of people just, just create a little script, run the script, it compiles everything for you. You can't do that. Well, you can do that actually in Xcode, but it's a lot harder to do it with Xcode. Xcode requires a Mac. Xcode requires the current version. Xcode requires everything to be up to date. It's very picky, very particular.
Many things for us actually. Whereas Eclipse and Visual Studio does many things.
Correct. Yeah. Well, Visual Studio does a lot for you. You can actually set up like an Apache server and do ASP stuff and test stuff out. And it does. I just say Apache, but anyway, long story short, it's more automated for testing and for debugging. Xcode, forget. However, it's the tool set is easier on the Android side. You're right. Yeah.
So writing in Xcode is like just like writing a program in Notepad.
Yeah, actually, it's very similar to Notepad. But, I can't stand it. Actually, I've gone through and I need to tweak this interface a little bit more because I have just upgraded the newer version. Every time you update the newer version, my old settings went away, and I got my new settings back. I got the original settings back, and I'm like, oh, I don't like that. I don't like this. Automatically putting in sets of brackets for you and automatically like typing ahead and stuff. I find some of that stuff irritating. Where Eclipse, not as irritating, actually. It runs a little bit slower. I think Xcode actually runs faster for me. But and the tool set, I can complain about the tool set, yeah. But I don't know if I would judge the language by the tool set, though. So, yeah. And that's everyone's biggest complaint is Xcode. Xcode is pretty. It's gotten better, though. To Apple's credit, it has gotten a little bit better. So, not the best. If you take the Android class, you'll find Eclipse a lot better. However, the Eclipse and the Android SDK and those emulators, terrible. Terrible emulators. Xcode, iOS, better emulators. Much better emulator support. So that's, if you talk about the emulators, well, you got to register. Okay, if you're going to use the built-in register that's on built-in emulators that are on the computer through the development environment, Xcode beats over Android SDK, 100%, 100%. Because those SDKs, Android SDK emulators are very, very slow, and there's too many of them. You can't figure out which one you want. However, it's easier to test on a real device on an Android, and it's easier to deploy your app on an Android than it is on an iPhone. So on the Objective-C part of it over here, you got to register a license with Apple in order to run it on your device, which is like absurd. You got to pay Apple $99. You guys don't have to, because I can give you a free one, education one, but you have to pay Apple $99 to run it on your device. And you're on the Android side of the fence, and it's free. You just drag it over, put it on the SD card and run it. Or put it on a website. Or you don't want to use the market, don't worry about it. You don't have to use the market. Just deploy it on your own personal website. Just put it anywhere you want. No contract, nothing. So you got some pros and cons. They're not in the same ballpark. So, all right, back to model view control pattern. So each of the three interacts together. And the parts are normally realized as an object with responsibilities of its own. We have three different objects. And the pattern itself is an example of divide and conquer strategy. And one big task is divided up into three smaller tasks and well-defined responsibilities. The model just handles the data and the orchestration of everything. Views just show stuff to the user. View controller just controls the view for us. So a example, the model might be a container class, such as an array. A view might be one element of the array. And the controller would be a given command or a set of commands to display the elements in a specific order or specific index that's inside of the array. And the model would notify the view to display a new element which is within or whenever the array contents change or anything different, the model would do something. So in an iPhone app, the model would speak with a broadcast receiver or speak with a sender of some sort and say, hey, here comes a new text message. New text message is coming in. And then it would tell the view, hey, put the little warning out there, tell the user new text messages in there. And the controller would respond when the user clicked on the warning and say, hey, I'd like to read this new text message. So all three parts have separate responsibilities. They're all looking for different things and doing different things within the app. So an application might be made to fit a model view controller, but it's particularly well suited for GUI. So GUI development, graphical user design, fits a better model actually. So we're not talking about model view controller generally when we talk about writing classes and inheriting classes. And what we're going to look at today is inheritance as well, or inheriting more objects from other objects. So model view controlled pattern here. What? Get people singing in the hallway. I'm sorry. I'm like, it sounds like kids, isn't it? Yeah. Is this the holiday season? Or is this trick or treating? Oh, here, wait a minute. Let me pause this. Well, at least it makes it interesting. Otherwise, it get kind of boring in here. You know. And we get the model view controller pattern. Here we go. So here's the model view controller pattern. We got the model in the middle. That's going to notify the view, hey, update something. And it's going to be manipulated by the controller. It manipulates it. So I'm going to show this to you, and you're going to go, okay, this is boring. But when we go back into Xcode and we start looking at building more apps, then you'll go, I'm going to say, this is the controller, this is the view, this is the model, over and over again. And then you kind of see, yeah, it actually does fit itself into a nice pattern. And you can use this pattern in Android. This pattern is used for object orientation. It's traditionally done through Smalltalk and through UML and through Objective-C. But it's now made its way over, and over here is the Java people. So it's made its way over into Java, into the Android. And I was actually kind of surprised. I'm teaching the Android app development course, and I installed the new version of the SDK last week or a week before. And I was actually kind of shocked. And I looked at it and went, oh, model view controller. Wow, it's actually more supported when you design a new XML interface file, a view. It gives you the controller that goes with the view already set up for you. I'm like, wow, it's actually on the same page now. So unfortunately, I'm learning this backwards, and the Android people are complaining because it's like, why do we have this? Why are we now getting a separate class with this new view that comes up? Why is this thing called that now? Why is it called an activity now? Why is it called the main activity? Why are we forced to use this naming convention? Because they're not used to it. So they're thinking forward at this point until they become more versed with it. But anyway, long story short, sorting pattern. I'm not going to go through the different patterns, but sorting pattern would be a way of sorting something. A merge sort is an example. These are all data structures, by the way. Quick sort. Well, it's algorithms and data structures. Algorithms and data structures follow design patterns. In fact, that's the interesting thing. If you're brand new to computer science, brand new software engineering, haven't taken data structures, algorithms, just know you're just learning a bunch of design patterns. It's all about design patterns for data storage, if you're for data structures. Or for, let's say, for example, algorithms. How are you going to sort something? There's like dozens of different ways to sort something, to search something, to find something. That's what your algorithms are all about. Are you going to do or a search? You're going to do a binary search. You're going to do a linear search. You're going to do what kind of search are you going to do? You take a data structures and algorithm course. You learn all the design patterns or what you're learning. So let's not go through all this stuff here. Patterns. More about model view controller. Let's talk about the history now. So as I mentioned before, I keep mentioning Xerox PARC and Smalltalk and all that stuff. So the framework pattern for reusable applications depends on the observer pattern. The observer pattern was the pattern before model view controller. So the observer is a design pattern in itself. It's incorporated into model view controller. Everything comes from observer. You're like, what in the world is an observer? It's like if you were not to get religious, although it is Sunday, if you're God or if you're some higher being, you're observing and you're controlling what's going on the planet or in the world. That's the observer. You're the being that's not really there. Well, okay, now that's why I say this is the controversial part. People will go, well, you might have different impressions of what this observer is. Might have different names depending upon your religious background. Some people don't believe in this observer. Some people do. So I'm not saying I do or I don't, or you do or you don't, or anything like that. I'm just saying that's the concept. You apply it to programming. Now you got the real world. So you got the observer who's watching upon and controlling. You're gonna die. You're gonna get garbage collected. You're gonna get instantiated. So all of the terminology to make a new instance of an object. So the originators go, well, it's just like the real world. Well, because we have an observer, we control how many instances of objects we've got. That's your population growth. we got who's going to be garbage collected, who's died and gone away, we don't need you anymore. Who is going to be controlled by who? Where are you guys going to reside in memory? Where are you going to go? You know, who's going to live here? Who's going to live over here? Who's going to control everything? That's a pattern. That's a design pattern of an application. That started out when it was first developed by Xerox PARC. And it was for Smalltalk 80 to run the original versions. And it was used by an application kit in a company, in a system that was called, in a company called NextStep. So it was a Xerox combination of a developing application kit for the language Smalltalk turned into a company. The company was called NextStep. That's where the NS is coming from, actually. So, used for Coca API for Apple's OS X. It's nothing brand new. It came all the way down through the lines, and it turned into the operating system platform concept. Recommended structure framework pattern in Java. Because remember, at the time, the Java people were looking at Smalltalk going, we want to make something more cross-platform compatible. Look at this thing called the internet's out now. And, you know, it's being used by mainstream people, which is actually kind of funny. Originally, when the Department of Defense put together the internet, and then they made it available for research in universities, originally there's like, if you go online, I can't remember what it's called, but there's like this famous quotes. People go, the internet, no one's ever going to use that, you know, and all these people said that nobody was going to like the internet. It was too hard, too complicated, you know. And why are you going to use that? You have so many other telecommunications systems, like the telephone, you know, and all these, you know, telecommunications, and the internet was a part of telecom to begin with. And then they went, you know, who's going to use it? And then the Java people are like, well, I think people are going to start using it. So they were like the first ones out there, to actually support it, actually, in terms of the language. Objective-C doesn't work too well on the internet. Not used for internet application development. Java is, though, and Java came out right at the same time period, or a little bit after Smalltalk, actually. So we got the Coca. I never figured it out. Probably one of these days I'll Google it. I'm like, what is Coca? Where is Coca, guys? Why do they call it Java, Coca? I don't know. I think somebody really liked coffee or something, or beans or something. I don't know. So, but that's where we're getting the next step from. So, and the observer pattern defines a one-to-many dependency between objects. So when one object changes state, all of its dependents are notified and updated automatically. Well, what is this dependence, or everything that's in part of it? You can think of the inheritance concept as part of the observer package as well. One object is also multiple objects in itself. So the is-a relationship comes out of this, where today I'm a teacher, I'm also a human. I also play golf, so some days I identify myself as a golfer if I'm on a golf course. I also go to the movies and actually be a normal human being. So it's like I change and morph as it is and the observer is changing those patterns for me. So who's the observer? Well, that's me. You know, you can go into the whole psychology of the person if you wanted to, you know, the superego, the ego, and everything else. But you have a self. Your self-being is changing and transforming you into what you're supposed to be. Like today you're a student, and tomorrow you're probably going to be an employee somewhere. Who knows? But that's the transformation from the It's not really inheritance, it's more of a object state, object identity transformation is controlled automatically by the observer pattern. Used to decouple the subject from its observer. Since the subject needs a little information to notify the observer, what am I going to be? Where am I going to go? And can result in excessive notifications. Yeah, and the object world, it could be kind of excessive. You have to explicitly say, you're a this, you're a that. You can also have an observer object in concept. And the object itself is saying, update this, update the observable object. And here's the observable. Add observer, delete observer, notify observer. So we have this information exchange that goes back and forth. It's kind of like how you tell yourself, what am I going to do for lunch? Actually, probably some of you are thinking about lunch maybe at this point. You're like, what am I going to do for lunch? Or maybe not. We have another hour. And you're the observer telling yourself that you're thinking about going to Subway's. Or you're thinking about, actually, I'm going to go to Subway's today. I'm thinking about lunch. Actually, a minute ago, I was thinking about lunch. That's why I brought that up. My observer is telling me, you're supposed to be concentrating on this boring stuff here, but you're thinking about lunch. I'm thinking, I want to go to Subway's today, actually, because I missed it yesterday because it was raining. So, I had donuts. Actually, I had donuts. I had bagels or something yesterday. So, yeah. I ate carbohydrates instead. So, anyway, long story short, I got all these messages going back and forth in my human brain. We actually have all these messages going back and forth theoretically in our objects. Do our objects really think? Do our objects really exist? Are they really control? Well, the controller is controlling the view. The app delegate's controlling the observer in that pattern. The observer is just really the concept of this thing, this being, who's controlling what this app is supposed to be doing. So, and then transactions happen. Things happen. As an example, if we look at this let's take a look at the observer pattern in a real world environment. And I'm going to just cut to the chase and tell you observer turns into event-driven behavior. They don't call it observer anymore. They call it event-driven behavior. Because somebody observed that you clicked the button. That's the observer saying, you button click. Touch down, touch up, touch inside, touch outside. Swipe to the left, swipe to the right. Who's taking care of that? The observer. What is it? It's an event-driven behavior. So if we talk about event-driven behavior, I'm just going to call it event-driven behavior right now because I really don't like to call it observer. Something happens, the observer comes in and says, what happened? This is what happened. I was thinking about Subways, that's what happened. No, I was thinking about controller, did a deposit, and then we set the change on a bank account, and then notify the observer, hey, they deposited something. What are we supposed to do now? Nothing. You're good. Okay, good. We did a withdrawal. Oh, what do we do now? Check to make sure they have enough money in there. Oh, okay, they do. Or no, they don't, or something. Update something. Get a balance or something. So it's the events that are occurring. So do you really program an observer, or do you get one automatically? The observer is actually built into the model. And so you can actually program the observer. We're going to look at this probably not till the third weekend. So if we progress through what's easy, views are easy. Temperature, conversion from one currency to, that's easy, that's easy. Some of the other stuff, we're going to do the jigsaw puzzle, then we're going, well, wait a minute, jigsaw puzzle. We got a bunch of pieces. We're going to move stuff. Then we change the observer to pick up the gesture. And then we control the behavior behind gestures. So when you're controlling the observer and you're programming the observer in a iOS application or in programming in general, you're picking up and you're identifying different behaviors and you're putting different actions on those behaviors. And you're doing it yourself, which is gives you control over the observer. So say when the user does this, then you do that kind of thing. So you're controlling the observer. You actually can create your own observer. How do you do that in Android is different than how you do that in iOS. In Android, for those people who are familiar with that, it's action listeners, button listeners, touch listeners, click listeners. It's the listener. The listener is the observer. It's out there in the background listening. So Android, Java, they call them listeners. Even in Swing development, it's called a listener. Action, button, listener, all this other stuff. In iOS, there's no word for it. We don't have listeners. We don't put listeners on anything, which is kind of weird, which is why another complaint, if I were going to start complaining about stuff, it's easier to control the listeners and the observers on an Android system than it is on an iOS system, because these are at least clear and they're given to you. These over here keep changing all the time, and we have no control over them. I can add a gesture, I can add things to it, but I can't control what happens when the user touches on something. And I can't make it so they can't touch on something, or I can't make it, I can, but it's more complicated. It's more convoluted. It's not as clear as it is on the Android side of the fence. So one of the biggest complaints, although you have so many gestures and you have so many things to do, you put too much of it in an Android, too much of that in an iOS app, you confuse the user, because then you touched it twice. You touched it once. It was a long press, a short press. So we're going to see that with actually it's going to be a press. We're just going to take a view, put it up there, and program some observers. Make sure that we can actually kind of get the concept of what that observer behavior the listener is actually doing. Because the listener's going to look, how long did you touch something? And did you move it to the right as you touched it, or did you move it to the left as you touched it? Unfortunately, you put too much of that in your app. User can't use your app. It's too complicated, and it doesn't work as expected, which is my biggest complaint with that. If you take that same thing, you put it on the Android, it actually works better. It's more sensitive. There's less of it, but it's more stable, in my opinion. That's just my opinion. So, over on the iOS part, I have a problem with the keyboard over here. I have a problem with when I touch on something, it doesn't pick it up because I'm touching too lightly or I'm touching too hard or something. It's too sensitive. So, in fact, the iOS 7 is more sensitive than the version before that, which is kind of like one of my pre-complaints on it. But I have to get familiar with it. I have to use it differently. Android, you don't have to have that same problem. Android, the swipes are clear. The actions are clear. The observer is programmable. The listeners are programmable. They're programmable on the iOS side. They're just more difficult to work with. Anyway, observers rock. So, after I said all those negatives, observer pattern allows the bank account to notify multiple views without minimal information. Observer can register themselves with subjects, no strings attached, and then the transactions would cause this design to collapse under, spurious notifications. So if you don't have anybody out there listening, you don't have anybody out there working with something, then it's really hard to control the environment. So observers are good. Observers are something that add more control. Here's some observer behavior in a little picture with the model view controller. Works with the same concept. Observers are part of the design pattern. So just think of it as nobody calls them observers. If anything, it's called event-driven behavior, event-driven programming. But if you really want to be technical, a gesture is picked up by an observer. The observer controls the gestures, controls what's going on with the interface in terms of the events. Set a state controller plays around with the, and this is actually not bad because it shows you the big picture model view controller. These are your view controllers. This is your view. They took away our views, now we have storyboards. We used to have XIBs, interface builder that built views. And we're going to actually add multiple view controllers with multiple views in one of the projects we're going to do this afternoon. So you'll kind of see today's projects will focus on all three of these items actually and reinforcing the model. Yesterday was kind of an orientation to the interface. Today we're going to work more with it. So I'll save that fun stuff for after lunch actually, when we're all tired, so I'll get entertained. The view here gets the state, updates the model. So, and then the model is the business logic. See, some people think the model, well, okay, the funny part about this is that the model is really what the delegate, is it really the model or is it the controller? There's a little bit of fuzzy area in terms of how that's implemented with the iOS platform actually. But it is the model, it's the data model. So, advantages of the separation between the data layer and the interface is the key. It's what you're focusing. Why you want to do this is a clear, definite roles, clear organization. It's like writing a research paper and having an introduction, conclusion, and body paragraphs. It just gives you more structure. It makes for a better paper, makes for a better app. The views easier to replace and extend, which is what they say about objects, which is actually kind of interesting. You can have multiple views, which is what you're doing with the storyboard, actually. You have one data model. You have multiple views. One view is for the iPad. The other view is for the iPhone. if you do the universal app type. Same views, two different views, same data, same model, same program. You just put components out there. You're loaded on an iPad, you get the iPad one. You're loaded on an iPhone, you get the iPhone one. Program's identical. You write one program. When I say write one program, I mean you're writing one app delegate, multiple view controllers, one set of data. Works on multiple views. Extendability. I have to give Apple credit for that. You don't get that on the Android side of the fence. You get one view manually created with another one manually created with separate controllers and separate. You don't get the whole convergence, but you don't get the same platform with the same hardware, which is what the problem is. So my biggest complaint on this side of the fence over here is that how do I find out if I'm making it for a Galaxy Tab versus a Motorola device versus, and then you have all these different drivers for all the different devices, for all the different hardware. Yes, you have a lot of flexibility, and you can write an app for practically almost anything, but you got to know what you're writing for, and you got to test it on that one. You got to buy like 20 devices to do the Android equivalent to 2 devices on this side, which for testing purposes, iOS is easier to test. Android is terrible in terms of testing, because how do you know what tablet they're running it on? And then you go to Fry's and you see all these off-brand tablets, or all these tablets, and people are going to load your app on the tablet, and it's not going to look as good because the tablet's got a really bad graphic adapter on it or something, or I don't know. Long story short, not as consistent, although you might argue the same point and say, well, it's not as easy to entry. You got 20 million Android devices. You got 2 products over here. Those products, if you've seen the commercials, are very expensive. So, I don't know. I could argue this all day. I'm going to stop arguing it, though. All right, so the advantages here. Replace, easy to expand the views. The model data exchange reflects all of the instances and interfaces because all the views are observers. So you put the view, in fact, that's the interesting part. You put the gesture on the view, and the gesture is part of the observer concept. So you're testing the view to see if someone touched it. Did someone swipe it? Did someone do something to it? Better scalability, since the UI and the application logic are separated. Yeah, much better. In fact, you have that. If you follow MonoView Controller with Android, you have scalability as well. You just have different XMLs for different devices. And you say, you know what, I'm going to support this API through that API level. You have the whole ranges of APIs for whole different levels of Android operating systems that are out there. You just make it a little bit more generic, so it looks pretty good on all of them. And you test them on a couple of those devices and you see what it looks like. And then you hope that the user is going to use one of those popular devices. And then you've got a pretty good Android app. So, distribution over a network is greatly simplified. Yes, when you have a model view controller. So, problems with it? So, problems of the translation. Yeah, the business logic. And the business logic blends into the controller. So, you'll see this. Actually, I have a really bad game example I'll show you, where I've got one controller that's controlling like 5 different views and the data's in the controller instead of in the app delegate. It's an example of a bad concept. And when you switch in between the different views, you have to repeat everything over and over again because it's not stuck in a centralized location. It's stuck in each one of the views, and each one of the views aren't controlled by the same or the right controller. You mess it up, it's really hard to actually figure out what the business logic is out of here, which is really a bad example. But it's actually good. I like to show that example because it makes something that was really simple into something that's too complicated. So, and that's different than what's on the slide here. On the slide here is going the opposite direction. It's like, I know what I want to do, then how do I translate it into the right components? Which is a different pattern, it's a different problem in itself. Also problems with the pattern. Excessive coupling between the model and the view and the model and the controller. Yeah, lots of coupling. Coupling is going to be determined by the interdependence and the dependency of it. So if you have too tightly coupled, it's not as flexible, not as exchangeable, doesn't work with multiple components. And you end up with multiple views, multiple view controllers, multiple everything, and you end up with more components than you actually need at the end because you can't interchange them, they're stuck. So excessive coupling is not so good. Frozen interfaces are hard to manage. Yes, they are. They're stuck by one controller that's frozen. You don't have any other way of getting to it. To unfreeze it, it's done. So the tighter you couple it, the more you make it into the model, the more strict you make it. More control it is, more safety there is in it. So I don't know, there's pros and cons. I've given you a lot of the pros on the model view controller. Part of the cons is the extra components. What if you don't have any data in the app? Why do you need all that stuff? Actually, we created 2 apps yesterday that didn't use any data. Why do I need an app delegate for any of that crap? Didn't need anything. All I needed was a view, really. What do you need for Hello World? You got like 20 files for Hello World? When all you needed really was one little view to put something on a screen. So you got lots of extra stuff. So, anyway, that's my spiel on the history of NS for NextStep. I don't know. Just know that it came from NextStep, and it's from the Coca interface, which is the history of it. Model view controller. We'll get into some examples when we start looking at the programming parts of it. So I'm going to stop this video.